Good morning, everyone. My name is Jowin Hua Wenqi from Science 1. Today, I will present Task 3, which includes two projects, Unplug activity and Plug-in activity, which using Scratch to show how computational thinking helps solve science problems. First, I will present Project 1, Unplug activity, create any scientific law or phenomenon. So, my scientific problem is, how does food spoil? This is the introduction for our food storage project. First, food cannot stay fresh permanently. Factors including temperature, air contact, and storage time speed up food spoilage. Spoiled food will have bad odors, color change or mouth, which is unsafe for consumption. Then we set a real scenario. A store owner hopes to extend food shelf life and needs to forecast which food will go bad faster. Throughout this activity, we will observe different storage conditions, find repeating spoilage patterns, and apply computational thinking to predict when food will spoil. So after the class, the students are able to identify factors affecting food spoilage, predict food spoilage under different storage conditions, apply the 5 city skills to solve a science problem, and evaluate prediction through observation and comparison. The material are needed are food cards and condition cards. First, let me briefly explain what is decomposition. Decomposition is the process of breaking a complex problem into smaller and more manageable parts so that it can be understood and solved more easily. Students need to apply decomposition into the scientific problem, for example, spoilage food. So students need to break the problem into smaller parts by identifying factors that affect food spoilage, such as temperature, time, and so on. So students can examine each factor separately instead of trying to solve the whole problem at once. It will help students understand which factors contribute to food spoilage and make the problem easier to analyze. Secondly, pattern recognition. Pattern recognition is the ability to identify similarities, trends, sequence, or recurring relationships within information. In this problem, students need to compare different food storage scenarios and identify similarities or trends. So students observe patterns such as food spoiling faster in hot environments and lasting longer when refrigerated. Recognizing patterns allows students to predict spoilage outcome in new situations. Third, abstraction. Abstraction is the process of focusing on the most important information while filtering out details that are not relevant to the problem. In this case, students focus only on the important information related to food spoilage, for example, time, moisture, temperature, and air exposure. And students ignore unimportant factors like food color and packaging design. It enables students to make accurate predictions by using only the relevant information. Next, algorithms. Algorithms are a set of clear, logical, and step-by-step instructions designed to solve a problem or achieve a specific goal. To solve this problem, students create a set of step-by-step rules to determine spoilage of food. Students follow a step-by-step procedure to analyze food storage conditions and predict the rate of food spoilage. For example, firstly, students identify the type of food, check the storage temperature and condition, and check if the food is in an airtight container or open container. Next, estimate the number of days the food has been stored. Besides that, use the rules to predict how fast the food will spoil. Lastly, record the prediction. This will help students investigate the problem in a clear and organized way. Next, evaluation, which is the last CT skill. Evaluation is the process of testing, reviewing, and assessing a solution to determine whether it effectively solves the problem. Students need to test their prediction using new food storage scenarios. For example, bread A stored in a refrigerator and bread B stored under the sun, and tell whether the rules work correctly. Students compare their predicted result with scientific explanation and discuss an error. This helps students improve their rules and make more accurate predictions about food storage. Now, we come to the summary of all computational thinking skills. This table shows out the full workflow of our research. We first read the food storage problem via decomposition, then find storage trends with pattern recognition, filter unless detail using abstraction, design operations that is an algorithm, and finally verify our prediction through evaluation. These 5 skills work together, letting us analyze food storage systematically and get reliable prediction results. In conclusion, the food storage activity shows how 5 computational thinking skills support scientific research. Decomposition spread influencing factors, pattern recognition find storage trends, abstraction filter unimportant details, algorithm build prediction stats, and evaluation check prediction accuracy. Combining computational thinking with science study strengthens student logical thinking. This kind of practical activity helps learners master both scientific knowledge and essential modern skills. This project will help students to identify factors affecting food storage, predict storage under different storage conditions, apply the 5 computational thinking skills, and evaluate prediction using observation. So that's all from my project 1. Next, I will show my project 2, which is Scratch. Now I will explain how I use Scratch to create my project. First, I use many sprites, including Jamie, bread, refrigerator, car, table, Ruby, bell, block ABC, error, and stop. Next, I use many backdrops. For example, bedroom, refrigerator, room, car park, and school. Besides that, coding is also very important in creating the project. First is the green thread. I use the green thread for my background music. When I create the green thread, my background music plays throughout my project. Not only that, when I create the green thread, it directly switches the backdrop to the first backdrop, which is bedroom. Also, when I create the green thread, the variables of score and question show. Finally, I also use the green flag to hide sprites that do not need to show in the first backdrop. Next, I also use a loop to background music which is dance throughout. When I use loop, the background music plays forever. Third, the condition which is that if then. For example, regarding the break, if it touch block A, the score will change. If it touch block B or C, it will say not correct and ask the student to try again. Besides that, I also use variables. I have set two variables, which are the questions and the score. Next, I use three sound effects. The first is dance throughout, which acts as my background music. The second is bell toll, which plays when the student click the bell. The last is chill. When all the questions are completed, an end button shows and the student click it, and it starts a chill sound. Finally, interactive elements means that the student can move something when playing the scratch. For example, when the student answers the questions, student need to move the braid toward the correct answer. If the student answers correctly, it will show congratulations, you get the correct answer. If they don't answer correctly, it will show not quite, try again. So that's all from my explanation. Next, I will introduce the objective of Project 2. First, we use Scratch to deepen learners' understanding of full storage science concept. Second, we practice computational thinking with digital programming. Lastly, the interactive simulation can make students more engaged during learning. So now we move on to integration of city skill. For decomposition, Project 1 identifies spoilage factors, but Project 2 breaks the game into smaller tasks and coding. For pattern recognition, Project 1 compares storage condition, but Project 2 compares different outcomes. For subtraction, Project 1 focuses on important variables, but Project 2 displays only relevant information. For algorithm, Project 1 predicts storage step by step, but Project 2 scratch block control the sequence. For evaluation, Project 1 compare prediction with observation, but Project 2 immediate feedback after answering. Next, benefit of the integration. After the class, the student can think logically, solve problems systematically, make predictions using evidence, improve critical thinking, and connect science with everyday life, and also enjoy interactive learning. But the teacher can integrate science and digital technology, increase classroom engagement, provide immediate feedback, support inquiry-based learning, develop higher order thinking skills, HOTS, assess students through interactive activities. So that's all from my task 3. Thanks for listening.